This biogas thing from night soil, which you have already heard, has not been accepted as a more or less like a blockade, mind blockade. Otherwise, there is no harm in using it. But let us see how we have Sulabh has installed plant sometime in 80s, and it is still functioning. And I would like to, now my presentation is more or less basic presentation sort of a thing on biogas from human waste, because there are a lot of parameters which I am considering to be taken care of while designing a night soil based biogas plants. You have heard a lot about the animal waste and agriculture waste, but this is more or less completely on biogas plants. But I am also facing quite a few difficulties which I will discuss with you people. This is a basic definition of biogas, which here we have added earlier, even in your film, you have not mentioned anything about human waste, whether that could be also used to generate biogas. But here there is a big component of human waste, and in fact, billions of methane gases, tons of methane gases are generated by human beings every year. Biogas is about 20% lighter than the air and has an ignition temperature between 650 and 750 with 20 to 26 megajoules. It is normal thing. As I have mentioned, this, as most of you must be knowing also, this is a 3-stage treatment process from organic to organic acids, carbon dioxide and alcohols, and then that is hydrolytic stage, first stage 1. The acetogenic stage is the next one, and the last one is methogenic stage. This, because we have to control the production, so that's why I am discussing this. This is being done by basically 3 types of bacteria, anaerobic and facultative, as well as aerobic and facultative, as well as anaerobic ones. This constitution is same. It has got some hydrogen, nitrogen, as well, water vapor, as well as traces of, but these are the few things I want to discuss specially. Factors controlling biogas formation, especially with respect to our human waste biogas plants. It is to run between 25 and 30 degrees. It is the best satisfactory gas producing takes place in that temperature range. It of course shows that gas production stops when the ambient temperature goes down around 10 degrees. But we have installed human waste-based biogas generator in Afghanistan with attached with the community toilet where the temperature goes below freezing point. What we have done is we constructed it about 1.5 meters below the surface ground level, and it functions perfectly well in any temperature. It works, and it's still working. It was done about 5 years back. Hydraulic retention time. As you know, most of our designs are around 30 degrees detention time. In India, it works quite well. We have installed, by the way, we have installed about 200 human waste-based biogas plants throughout the country. So some of them are, of course, one of them is already located in our premises that I will discuss later. And another biggest one is in Shirdi, where 3 biogas plants are working, and daily users are around not less than 5,000. Sometimes it goes to 15,000 people using the toilet system, the community toilet system. So we generate, in fact, we have got 3 digesters over there working. So we can increase this day to even, they say around 70 to 80 days also. But the retention time is, if it is too short, the bacteria in the digester are washed out, and the fermentation ceases. Conversely, when the retention time is very high, there is an increase of in gas production, but die-off of the different pathogens takes place. Loading rate is also an important factor. If the plant is overfed, acids will accumulate and methane gas formation will be inhibited. Similarly, if the plant is underfed, the gas production will come down. Nature of substrate and feed material. Most of the bacteria require micronutrients for growth, like carbon, nitrogen, phosphate, potassium, oxygen, and others, are available in both animal waste as well as human wastes. But we are more concerned about the COD and BOD ratio. A COD-BOD ratio of lower the ratio, the more is the biogas production. So we want to keep it as low as 2.4. In the night soil, it remains around 2.4, which is biodegradable and it functions pretty well. Inoculation, in any case, we have to inoculate it either by gobar or anything, something like that. Generally, we do it by gobar, that is cow dung. And the growth rate occurs between 10 to 20 days. In case of semi-continuous and continuous flow, it settles down. Another 15-20 days time, it functions pretty well. A 20 to 25% volume of inoculums are to be given to get these optimum results. pH is another factor which is to be taken care of in this type of plants. It should be around 7.2 to 8.2. Below 6.5, it stops functioning. So that control measures are to be taken. Another major factor is carbon and nitrogen ratio. The optimum biogas production in CN ratio is between 25 to 30. But in human excreta, the first figure over there in the presentation, it's around 8 to 10. But still it functions. And we are getting good quantum of biogas, and at least we are being able to use it regularly. Though in that ratio also it is functioning pretty well. And we find that this is good for human waste, but not for other waste. Maybe in chicken dung and others, the ratio is low, maybe mixing, but we have not experimented with that, but this could be discussed separately. Mixing and agitation is required. Agitation, proper mixing and digester content helps substrate available to all groups of bacteria. The bacteria family population density becomes uniform and scum formation doesn't take place. Stop. Dilution consistency and consistency of the inputs. In case of cow dung, of course, it is required. But in case of human waste, dilution is a big problem. Because it doesn't work, we have to have low water availability, and that is a bigger problem. That I will discuss later. Thus, these are the spatial capacities of plant, 1 to say 140, 200, 400, whatever is available. But it is very difficult to have big human waste-based biodigesters because the quantum is so small, and to carry that from a long distance, it is a very difficult job. And because water content has to be kept low. These are the basic cost of biogas plants that we have designed so far. That is from 9 cubic meter to say, the Delhi plant is around 35 cubic meter, 30 cubic meter per specific. It was constructed long back, 80s, as I mentioned. Now, this is just a comparative study that we have done. for different type of wastes. Just for instance, size of the biogas, and for peak droppings, how much of quantity is required. And if you say a design of 60 cubic meter, the last figure, a 60 cubic meter biogas plant will require waste of 3,750 people. It's a huge number. To get the waste collected from, and that too in a low water content, and to bring it to a place, to one spot for the treatment is a big issue. Because I have myself faced this problem. We were designing for Delhi Police College, they are having barracks. Each barrack has got 200 people. And presently they are asking for 1,200 people to be served. Now, to get the waste flowing from the last barrack to the treatment plant, we have to go down by about 3 meters first. Then again, since water used in those toilets is very low, that is requirement of this type of digester. To make it flow is a big issue. We have to flush it. And we are trying to add some other waste, maybe cattle waste, to make this digester functional. So we are designing for that, and we are finding it difficult, in fact. Because as in the next slide, I have mentioned, the cattle waste, 10 kilogram of cattle waste each animal provides, and it gives a 0.36 cubic meter of gas per day. Whereas individual single human gives about 0.4 kilogram of waste, generates, and the gas generated is 0.03 cubic meter. Now, you have to clean and flushing should be limited to 0.5 to 1 liters per capita, per wash. So little water, so small quantity of waste, it is a difficult job. So we have to flush it occasionally. And if you flush it, the quantum of water in the generator goes up. And we have to have another sort of a waste to be added to make the generator functional. There are some advantages, of course. Most of you know about that. On-site farm energy, this has been discussed since morning. Reduced odors, again. High quality fertilizer, that is a biggest advantage of this digesting sludge, which could be directly used, and reduce surface and groundwater contamination. And the pathogen reduction is very high. If your digester works pretty well, you can remove it by 85% up to. But if your water availability is hard water, this percentage comes down, that we are witnessing in our treatment plant. This has got a very high NPK value as well, human biogas manures. As you see in this, fresh cutting down, and we have given the figures. This is for research purposes and studies also. That's why we think that it could be a very good manure, and organic manure too. Now, these are fixed dome digester and floating drum. We have mostly constructed the right-hand side one, or for you also it is on the right. The one that is located in our place is this one, the second one. This is that plant. The green building that is you see in the background is our community toilet. It is being used by about 1,200 people daily. This whole thing, waste from that, comes to our digester, which is about 15 feet below ground. The plants that you see, the digester is below that. And then, because this was constructed about 30 years back, so we had a separate digester and gas holder. The one you see is that gas holder over there. It is written gas holder, black one. Now this is about 30 cubic meter capacity. And as I have already mentioned, around 200 of this has been constructed. The one is RCC constructed one. These are some certain parameters which we used to design our systems. There's minimum flow is only 4 liters per day we are taking. So these are, I'm not going to explain all these things. This is gas storage space is around 50%, feed material flow is gravity flow. In case we are thinking of having human waste as well as animal waste as a combined one, which is feasible, and there is no problem, hopefully not. At least people will use it, thinking that it is animal waste and not a human waste. Then we have to see that, the pipe, there should be separate pipes for inlet. The human waste one should be lower than the other one, the animal waste one, because otherwise backflow will take place in that, because the quantity is low, it takes place. So what we have designed is like that, the human waste pipe, which is taking the the waste in, is lower by a feet or 1.5 feet above the other one. Now we have used this biogas for many purposes, whether it is mantle lamp burning, but regularly we use this gas for cooking purposes. Every day food for around 40 to 50 people is being cooked by this gas, and we consume around 7 to 8 cubic meter. We don't require more than that for this. Then there are various factors. We have also got a generator, but we don't run that regularly. It is more for a demonstration purposes. Earlier we had a diesel plus biogas, but we have converted into, it is a completely diesel without any sort of a treatment biogas. We are using directly in that generator, and it works pretty well. And many people have taken, because ours is more sort of a demonstration pilot project. It is not a regular working project like that. But gas for cooking is regularly being done. Others are just to show that this you can do this, like that. This is another technology that we have, the effluent coming out of the digester. We recycle that water through sedimentation tank and filtration, then activated carbon and UV tubes. And the BOD is brought down to around 10 gram per liters, or 10 ppp you can say. This, we are using about 2,000 liters of water like that. We recycle the whole thing. The sedimentation tank has got a 1.5 hours settling. Activated carbon, around 10 minutes of passing time thing. And then filtration and aeration is also. Then there are some problems that we are facing regularly, because there are a lot of our plants located almost all over India. Especially leakage in some cases, but whenever we have got RCC one, there is leakage is less. But anyway, that is to be taken care of. Inoculation of digester, that has to be done regularly if it is not coming through, because that is a problem we are facing, because waste, we are not getting waste always, the quantum we require it to run the system. Production of gas production starts on the 8th day of inoculation generally. Initially, it contains more carbon dioxide. Gradually, percentage of carbon dioxide goes down, and it is, by 20 days, it functions pretty well with methane. We remove the water from the gas pipe by traps that we have already provided. Scrubbing of unwanted gases already has been discussed in other, it is the same thing. There is nothing new in that. Now this is some sort of a different application of the biogas and how much we generate, just a guideline for that. So 30 cubic meter of biogas is equivalent to about 600 cubic feet of natural gas, 6.4 gallons of butane, 5.2 gallons of gasoline, or 4.6 gallons of diesel oil. Then if you run the burner, how much hours and how much consumption of biogas, these are the things. In electric power, 0.75 meter cube of biogas is almost equivalent to 1 kWh, that is 1.3 kilowatt hour. Thank you.